It's space weather! Check it out. You see that? See what we're looking at? Sunspot 2726. It's got a powerful magnetic field associated with it. Let's take a look at 304 angstroms, as there is a massive plasma filament also down in the southwest limb. Not exactly loading fast today. There we go. Let's watch this thing form. You can actually see the magnetic fields interacting there. It's pretty cool. And let's take a look at this giant plasma filament. Check that out. It's a big one. It's about 3 times the diameter of the Earth. And here's your magnetic lines. You can see strong interaction with these regions here. And we are expecting an uptick in the X-ray flux as a result. Take a look at the earthquake situation. The last 8 hours. And we've got another mid-Indian ridge quake. Another 4.4 off of Svalbard. Pretty rare. Vanuatu got a 4.3 at 661 kilometers depth. So Vanuatu stays on alert for a mid-5, 5.5. Greece hit again with a 4.6 and a 4.8. No other quakes of note. Let's look at the spaceweathernews.com. See what's going on with the in-depth data. All right, and we do indeed see a slight uptick in the X-ray flux. No surprise there. No magnetic connection indicated by a phi angle signal. Solar wind density has dropped down again. Looks like about 4 protons per cubic centimeter. And the solar wind speed remains elevated at, looks like it's around 600 kilometers per second. That's the old coronal hole wind stream. Now we can see steep spikes in the magnetometer. Best guess is that that would level out and not get super high. However, when this is going from low phase to high phase, earthquake risk is actually very high. KP index is at 3. Electron flux did soar yesterday, and we would not be surprised at all if we saw this get above 10 to the 5th today because of those because of that sunspot group. It's looking pretty powerful. A little bit of charging hazards, and the F2 layer is actually discharged, so that's probably going to charge up today. There's your auroral forecasts. Now, take a look at solar ham. Solar ham does not show this sunspot named yet, but it will be named, because they're not going to miss that one. That's a real sunspot. It's not big. And oh, it seems like it's getting more magnetically more magnetically complex. So yeah, keep an eye on that. And here's the location of your planets. Still chasing Venus and losing the race. Dropping Mars as Mercury catches up. Go outside and look at the sky just before dawn today. In the east, you will see an incredibly bright Venus. Or if you prefer, go outside with a telescope at midnight and look straight up Uranus. Now, let's talk about Milankovitch cycles. Well, what are the Milankovitch cycles? Well, there's a lot of talk about climate change nowadays, right? What causes the Earth's climate? Well, Milankovitch cycles. At least for the last, say, 80 million years. And what causes a Milankovitch cycle? Well, there's 3 different factors. 1. Eccentricity. The Earth's orbit is egg-shaped to almost perfectly round. When it's perfectly round, it's closer to the sun. When it's egg-shaped, it's farther away. This is known as orbital eccentricity. Now, for the record, Earth reaches maximum orbital eccentricity in the year 2024. Next, we've got the tilt. So the tilt of the Earth's axis varies between 22.2 and 24.5 degrees. The greater the tilt angle, the more solar energy the poles receive. Lastly, we have the precessional wobble in the orientation of the Earth's axis. This is the thing that makes the star Deneb, the North Star, at the other end of the precessional cycle, and the star Polaris, the North Pole in our current cycle. So, the precessional tilt, the precessional wobble, is a 19 to 24,000 year cycle. The axial inclination is a 41,000 year cycle, and the eccentricity varies over 95 to 400,000 years. So if you see this, you can see that the planet spends a lot more time cold than it does hot, and these little tiny spikes, well, those are what allow you to exist. When both poles are frozen, it's an ice age. So, since both poles are frozen, you're already in an ice age. Now, let's look at the last cycles. See this? See that little spike there? That is all of human history. At least all of known human history. Because in the current state of affairs, the Earth is an ice planet. Now, let's check out the last 10,000 years of climate change. For all those people who are claiming it's the hottest whatever ever, here's the last 12,000 years. If you notice, the Minoan warm period was much warmer than the Roman warm period, which was much warmer than the medieval warm period, which was much warmer than the current warm period. And you can see if the temperature drops about 1 degree, you're going to fall right off a cliff. This area over here, that's the planet coming out of the last ice age, the Younger Dryas event. So yeah. All we have to say is that mankind and carbon dioxide has absolutely nothing to do with the Earth's climate. Are we entering a grand solar minimum? Probably. The solar cycles the way they are, and radio astronomers believing what they do, those who know how to study the magnetic dynamo, such as Zarkova, agree that the planet is getting colder. And everybody who knows how to look at the big picture tends to agree. So, increase your carbon footprint, people, I implore you. Put more plant food into the atmosphere so we can grow more plants as the sun cools down at the same time the Earth reaches maximum eccentricity. Enjoy the frigid temperatures, and may the solar wind be at your back and the atherosclerosis absent from your arteries.